Welcome in. All right, so this is the introduction kind of unit with regards to several questions. And I think it's worthwhile if you're going into your first physics class. So depending, maybe in grade 11, maybe you're even doing this in post-secondary, to run yourself through these examples just to see, what you might want to be able to brush up on. This unit is not always done by instructors. I like to just kind of put these questions together to let students know, what should they kind of review and go over. So let's dive in. I'm going to do every single question. I'm going to actually also provide you the PDF. So you can look up in the show notes or in the description. You can download this. It's going to be a PDF document. And what I also will do is I'm going to numerate so that you can go to any question you like in terms of the solutions. So if you go back in the description, or if you scroll through the actual video, you'll see the actual answers and solutions numbered. So you don't have to actually watch, you can just go to the one that you might be interested in. All right, so let's dive in. So let's take a look. So this is going to be question number 1. I'm going to go through the first few relatively quick fashion. So for number 1, it says that we want to be able to convert this. It is in scientific notation, and we want to be able to convert it to decimal representation. All right, so 10 to the power of 4. So that means we're going to have to shift that decimal over by 4. So this is going to be 37500. And you can see that what I've done is I've just simply shifted the decimal. So 1 spot, 2 spots, 3 spots, 4 spots. Okay, that is the same thing in terms of the actual exponent itself. If you want a little bit more, okay, and more examples with regards to this, which is scientific notation to decimal representation, I'll put up a link up above there for you as well. All right, so here is the second question, okay? So question number 2. So for question number 2, what we have, so convert, so now notice it is a measurement, so it's 0.0021 grams. We want to put this in scientific notation. So in scientific notation, we need a mantissa, so this is going to be 2.1 times 10, and now we're going to be shifting the decimal over 1, 2, 3 spots, okay, but it will be -3, so this is what we would have, and if you want to put in the units, okay, you can certainly do that. So that's what the answer to this would be. Question number 3. So let's dive into this one. So for question 3, we have convert, and now it's a relatively big number. So it looks like it's 270,000 seconds to scientific notation. So this is going to be 2.7 times 10. And now I'm going to actually count it up. So I'm going to just go in here. So I would shift this 1, 2, 3, 4, and 5. So this is going to be 5. And this is going to be positive, and this would have been seconds right there. So that's question number 3. Question number 4. So that's this one right there. So convert, and this will be, so 1.1 times 10 to the -5 meters. We want to be able to convert this to decimal. So this is going to be just shifting things over. So this is going to be 0 point, and now notice because of the -5 right there. So that's going to have, now is the 1, 2, 3, and this is 4, and then I need my 1, 1. And again, so this is just, okay, this would have been 1, 2, 3, 4, and 5. And that's because it's negative, so we're going to be shifting this over to the left, okay, there, that decimal from right here. And then you can put this in meters if you wanted to. Okay, so that's question 4. Question number 5. So for question 5, it says the diameter, and I'm going to actually kind of steal this out from here. So let's borrow this entire thing. So copy it. I'm going to bring it down and paste it. So there we go. So this is question 5. The diameter of a virus is about 5.1 times 10 to the -7 meters. So this is what we have been given right there. How many virus strands would you fit if you lined them up side by side in a 1 meter length. Okay, so, well, okay, so this is what this is saying. So if you have a virus, okay, and it says a diameter, so it's almost like it's relating it back to a circle. So let's imagine we do have a circle, and that's your virus. And what it's saying is that this diameter, so as you're going to be going from here to here, so diameter is right across, this is equal to 5.1 times 10 to the negative 7, okay, meters. And what we want to be able to do is we want to be able to see how many of these we would be able to fit in, right, side by side. So if we were going side by side and we're duplicating these all the way through, of course, I'm not going to do that because we would have to do that all the way, okay, to cover 1 meter of length. So how would we do this in terms of math? Well, so what this would say is that we need, okay, so we're covering 1 meter. And now what we're going to be doing is we're going to be dividing this by 5.1 times 10 to the negative 7 meters, okay, per 1, okay, virus. And now notice that the meters will cancel and then the virus will go up on top, okay, as your unit. This will just tell you how many virus strands you would actually have. So you would have to take out your calculator here because you're dealing with the scientific notation. So it's 1 meter divided by, and I'm going to put this in brackets, so 5.1. And now you can, directly put this as times 10 and then to the exponent, and for me this is negative 7. Close the bracket, I'm going to hit equals, and notice that it's quite a lot of strands that this would be. So within here, so this would be round, it says round to 2 significant figures, so I'm going to just round this up, and this is going to be equal to, so 1,960,784. I don't need the decimal places because 2 significant figures, okay, would have been just these two right there. So now, in order to do that, you would put this back into scientific notation. So this would, well, the 6 would actually make that 9 go up. So this is going to be 2, okay, 0.0. That is 2 significant figures times 10. And now this was shifted 1, 2, 3, 4, 5, 6. And that's how many virus strands you would have right there. So this is a good exercise, forcing you back into significant figures. All right, so with regards to that, I can put up a link on significant figures right there for you as a review. And it also forces you to kind of understand what the question is. All right, let's take a look at another question. Question number 6. Is the estimated digit significant? Yes. The estimated digit is significant, means it is part of the measurement. What does it represent? All right, so this is a little tough one. What it represents is it is the last significant digit, okay, in your measurement, and that last significant digit has been approximated. It has not been precisely stated. This is tricky in a sense. So what I mean by that is, imagine that you were measuring something, and I'm just going to draw something out for you just so that you get a sense, okay, of what this is. Let's imagine that you have some kind of a height. Let's say this is the height of something. I don't know what it might be, a ladder or something like that. Now, you wanted to be able to measure this. And what would happen is, let's say that you were measuring this, and this, I'm going to just separate this out, okay? This would have been 1 unit, all right? Let's say it's a tiny ladder, all right? So in centimeters. So let's say this is 1 centimeter. And now what I will do is, okay, so I'm going to take this out, and I'm going to duplicate it, right? So measurement, okay, so this would have been now 2. Duplicate it again. This would have been now 3. I'm going to duplicate this again. And now you notice, well, that's interesting, because this thing, as I zoom in, so it's 1, 2, 3, but it's not 4, right? It's definitely not 4. So what it is it looks like it cuts off somewhere over here, which is definitely less than that. So this would have been, you would have been writing this out as a measurement. This would have been 4 point. Now you can still tell that it's definitely, well, it's more than half, it looks like. So this is probably like 0.6 or 0.7. I'm going to just put 0.7. So this would have been 1, 2, 3. I apologize. This is 3.7. And what I mean by 3 is 1, 2, 3. Let's say it was centimeters. And, you know, this is the height of it right there. Okay, and what I'm saying that from here to here is 0.7. This was the estimated digit. It was the last significant digit in the measurement, and we actually guessed it, right? So we were guessing it, but it's still significant. All right, so I hope that helps you out, okay, in terms of thinking of what that is. Question number 7. So let's take a look at this one. A heart rate monitor shows a reading of 105 beats per minute. How many significant digits does this measurement have, and what is the estimated digit? Okay, so this one is not that hard. So 105, so that is 3 significant figures, 1, 2, and 3. Now, what is the estimated digit? The estimated digit is always the last significant digit that you count. So that would have been the 5, right? So 5 at the end. So that's question 7. Question 8. A patient's temperature reading is 37.0 Celsius. How many significant figures, okay, or digits does this measurement have? What is the estimated digit? Okay, so that's also an easier one. So this will also have 3 significant digits, 1, 2, and 3. And again, for significant digits and counting, you can go back, okay, to that link that I pointed out earlier, okay, in the video, okay, when this was first introduced, okay, and this was within question 5 or question 6 when I was taking that up. All right, so within here, so this has 3 significant figures, or 3 sig figs, and the estimated digit is actually the 0, right? So it's the last one, okay, because we have the decimal, then that 0 will count. So that would be the estimated digit. 9. A sample contains, and this now tells us, okay, it contains this much of vitamin C. How many sig figs, and what is the estimated digit? All right, so this one, if we were counting this up, so this would be, well, the zeros to the left, they never count. So we have to start from this. So that would be 1, 2, and this 0 would count. So this also has 3 significant figures because we have a decimal in the number, and the estimated digit would have been your last 0. All right, so your last 0 would have been that estimated digit. Question number 10. Why do you think we even have significant digits? What is the reasoning for introducing significant digits and estimated digits into measurement? Well, so this actually goes back to the idea, okay, and this is back to question number 6 and the explanation there. So why do you think we have significant digits? Well, the reason is because our measuring tools we have are not perfect. As you can see, the height, the measuring tool that we will have, is not perfect. We do not have infinite number of decimal places that we can hold. So we have only a certain amount of precision. So that is the reason why we have significant figures, because we can only have so much precision in our measurement. That is, certain amount of decimal places or certain amount of significant figures based on the measuring tool we have. Now, what is the reasoning for introducing significant digits and estimated digits into measurements? Again, that is because precision. So we want to know when we're reading a number, how much precision, how accurate that is. There is a big difference, for example, if you're going to be thinking about this, so in terms of significant digits, if you say your measurement is 1 centimeter, and then your measurement is 1.0 centimeters, or you say 1.00 centimeters, etc. This has only 1 significant figure. This is 2 significant figures. This is 3 significant figures based on the way the numbers have been written. So it gives us more precision. So this is not very precise. It's basically like we're guessing. that it's just 1 centimeter because it has 1 sig fig, which means that has been estimated and guessed. So we didn't even really use any tool, we just eyeballed the measurement. While the second one, 1.0, now brings in a little bit more of precision. And now we started to use some kind of a tool to measure. And you can continue on and you can bring in more and more precision into your measurements. Question 11. So now we're going to get into some unit conversions. All right, so this is going to be a long one because there's quite a few of these unit conversions here, which I think are worthwhile for you to try. So we want to be able to do these and then round our answers to the same number of significant figures as the original measurement. All right, so this is a good kind of introduction not only to unit conversions, but also to think about significant figures, right? And then being capable of rounding them up. All right, so let's give these a try. So I'm going to do these kind of one by one as we're going through. So for part A, okay, so that's for this one. This is 3 significant figures. We're going from centimeters to meters. So this is really nothing else but just a metric prefix conversion. You can put up a link up above there to metric prefixes, right, if you want to go over that. So for this, metric prefixes, so centi, right, so that's just 2 decimal spots over to meters. So this is very simple. This is going to be 2.67 meters. So that one is relatively easy. Okay, part B. So now we want to go from, now this is seconds, and we want to go into hours. So this is going to be a little bit more challenging for us right there. So for that, so that's for part B. I'm going to write this out for myself. And now I want to convert it to hours. So first of all, I don't want to have seconds. So 60 seconds, that's equal to 1 minute. So the seconds will cancel. Now I don't want to have minutes either. So I know that there are 60 minutes in 1 hour. So that will cancel. And I'm just left with hours. So there you have it. So this is going to be 1230. Okay, and it's divided by 60. And then that answer divided by 60 again. And what we have is, so this had 1, 2, 3 significant figures. So I'm going to put this as 0.342 hours. There you have it. All right. So that's for part B. Okay, part C. So that's this one, which is next. So 42.5 grams to kilograms. Great. So this is another metric prefix. So those ones are very easy. So you're going from grams to kilo. So that means that you're going to be shifting 3 decimal places over. So that is going to be 0.0425 kilograms. So you're going from grams to kilo. So notice what I did was I shifted it 3 spots over. Let's make sure that we did that the correct way. So we went 1, 2, and 3. And there you have it. Okay, it stays with 3 significant figures right there. All right, part D. So now we're going to some area calculation. So this is 1.9 feet. And notice right here, they're giving us the ratio. So far, I didn't use any ratios because we had prefixes and then time. Those you should know as a student. So now next, so this is going to be 1.9, and this is feet squared. So feet squared. So there you have it. And now I can go in. So there's several ways to be able to do this. Now, first of all, I don't want to have feet. I want to have meters. And that ratio, it tells us that 1 meter is equal to, so there's going to be 3.28 feet. This is equal to 1 meter. And now notice because it's squared, so we're going to have to square this, or you can multiply it 2 times. So we can square it this way. And we're going to get exactly what we want. So the feet squared will cancel, and we're going to get meters squared. So let's see what that gives us. So 1.9, and it's going to be divided by, so 3.28, and it is squared that we're dividing by. So that will be our answer right there. And we have 2 significant figures. So this is 0.18 meters squared. All right, that's the answer for this one. Part E, let's jump into that. That will be this one right there. So I'm going to remove this. Okay, so delete. Now we're going from centimeters and cubed, so this is a volume, to inches cubed. Now, I do have, notice that inches, okay, right there. Oh, and this right here, so this should actually say centimeters. Okay, so this will be, I'll fix that in the actual downloaded document. Okay, so you have that. So let's take a look at this. So 1 inch is equal to 2.54 centimeters. And so for this, I'm going to write this out. This is centimeters cubed. So again, so you're going to be going through. So you don't want centimeters, so you'll put that at the bottom. So 2.54. You put the 1 inch, okay, on top. That's what you want to be able to convert to. And now notice, because it's cubed, right? So this is cubed. You want to be able to cube, and you are cubing the entire thing. So now with this, so again, so I can try to go ahead and see what we're going to get. So 14,000, and this is going to be divided by, because there's a 1 on top, so I don't need to really cube that. But actually, I am going to do this just for sake of completeness. This would have been 1 and divided by 2.54. So if you put that all in brackets, then you can actually cube this directly like this, and then you have now inputted it into your calculator. So if I hit equals, so this is what I'm going to get. Now this only has 2 significant figures, so I would actually round this to 850, and this would have been inches cubed. All right, so there you have that. Now let's keep moving along here. So the next one, that's this one. So we are going 9.1. Now notice you have meters per second. So this, even if you haven't taken this up, this is a great practice for yourself to be able to try to do these unit conversions. Okay, so within here, I'm going to actually shift this just in case I need some space. So how would I approach this? I approach this one at a time. So because it has 2 units, 1 on top and 1 at the bottom. So far, all the other ones were just 1 unit. Now I have 2, 1 numerator, 1 denominator. So let's get rid of the meter. So I want to get from meters to kilometers. So that's not very difficult, actually. So 1 meter, right, and kilometers. So 1 kilometer is actually equal to 1,000 meters. But you can directly do the metric prefix conversion, right? So you can go from meters to kilometers. And this, if you do that directly, okay, so changing the meter, the second I'm going to, in the denominator, I'm going to leave as is for the moment. So now switching this over, so this is going to be kilo. So this is going to be shifting it over, so 3 decimal spots, so 0.0091. And this is now kilometers per second. So what I've done is I've just changed the meter to kilometers. Okay, notice 1, 2, 3 spots. That's the kilo. Or you can just simply say that 1 kilometer over 1,000 meters, right? Because that's what they equal. Okay, and then that will give you what you need. Now, to get rid of the seconds, and you want to have hours, well, this one is going to be a little bit annoying. So now get rid of the seconds. So there's 60 seconds in 1 minute. And then there are 60 minutes in 1 hour. So that gets rid of your seconds. This gets rid of your minutes. And now you have to multiply the whole thing. So this is going to be 0.0091 multiplied by 60 and multiplied by 60. We don't need to divide by 1 because that won't change anything. And this, notice 2 significant figures here. So this will be 33. So that's rounded. And that would have been kilometers per hour. All right, so that's how you can do that. Okay, so there you have it. Now, if you really were keen, okay, on this, you can certainly do this one. Let's take a look at the next example. So I'm going to just kind of go over the next one right there. Let's delete this and let's shift this over. So now we're going, so this one is going to be a challenging one. So notice 2 meters, okay, so per second squared. So that's going to be annoying because of the fact that we have the squared, okay? So this is really a big challenge. Now, if you want challenges like this, okay, I'll put up a link up above there if you want some more examples. So how would I do this? Well, I'm going from meters to kilometers. So that we've actually just done. Okay, so this is not going to be a very big deal. So this is going to give us, okay, so 0 point, and this is going to be now 0, 0, 2. And that's going to be kilometers, and we have done nothing with the seconds squared. All right, so that's the first one. So just do it one at a time. That's just a prefix changeover if you needed to do that. Now, next, maybe I'll switch colors. So now we're going to have to multiply, and we don't want to have the seconds. And this one is going to be a little tricky. So first of all, seconds, so well, 60 seconds, right? And that's going to be, this is 1 minute. So that's that. But now, notice that it's squared, right? So I have to kind of square this out so that I get rid of this seconds squared that I would have. And now next, if I have the seconds squared, well, now I'm going to have minutes squared. So this square is now right here, and I want to get rid of, so this is now next, okay? It's going to be getting rid of the minutes. So now there's 60 minutes, okay, in 1 hour. Okay, that's what we want. We want it in hours squared. But now I have to square that again. And this is a little annoying, right, to think about this, but that's how you would have to do it, okay, in order to be able to get the right answer. Now, I also want to be able to point out to you that you can, so forget the square at the moment. Now imagine, okay, so if you're going back in here, if you wanted to get rid of seconds, you would just say 60 seconds over 1 minute, and then times 60 minutes over 1 hour. And that would just get rid of one of those seconds to change it to hours. And now you could square this, and this would give you exactly the same thing. Let's try to see what this actually gives us overall. So this would be 0.002 and multiplied, and I'm going to put all of this in brackets. Now notice, putting it in brackets won't actually be very difficult because I have 60 over 1 multiplied by 60 over 1. So the 1, well, we don't need to divide by 1 because it won't change anything, but we certainly have to go 60 times 60. And then we have to square that, right? So both of them squared. And this is going to give us a relatively big number. Now this only has one significant figure, 2. Okay, so rounding this off, so this is going to be, so 3, because you have a 5 right afterwards, so it's going to be 0, 0, 0, 0, right? So you can write it in this way, and that's going to be in kilometers per hour squared. So it's relatively a big number instead of the 2, okay, that we would have, but that's how you would do it. Okay, so this is a nice challenge for you in order to be able to see that. All right. H. So now for the next one, so that's this one, 18 GTTS, okay, into ml. Now you might have no idea what GTTS, okay, is. Okay, this actually is a shorthand for, okay, it's Latin and it means drops. So this is saying drops. So 18 drops. This is very common in healthcare where you have drops, right? And you want to be able to sometimes convert to the number of, okay, milliliters. Now in this handout, what I would encourage you to do is if you're reading, okay, so here it actually gives you, okay, a little bit of a piece note on GTTS, all right, and then what it is, okay, and then what it stands for. Okay, so I would encourage you to look that up, okay, if you want to know a little bit more, but we're just interested in the actual conversion. So this is not going to be very difficult, GTTS. Now we want to get rid of this GTTS. I'm going to actually go back. Notice that right here, it says that 1 milliliter is 15.9. Now this doesn't mean that it's always that, but this is now a very easy conversion in comparison to the one that we just did. And this would be for milliliters. So this is gone, and that's very simple now. So 18, and that's going to be divided by 15.9. Now I have two significant figures, so this is just going to be equal to 1.1 milliliters. All right, so that's what you would have in here. So not very much, right? So this is saying that it's like 18 drops, okay, that you would have per 1 milliliter, okay, within there. All right. Now, of course, okay, so this is just based on kind of unit conversions. Okay, so now next, okay, let's get rid of this. Let's see what happens. Now we have some time conversion. This forces you into time again. And these ones are not that difficult, I hope. So 5.7 now hours, back into seconds. Okay, so now we're going in reverse. 1 hour, 60 minutes. And then, notice it's not squared or anything, so this one is much easier. So that cancels the hours. Now we want to get rid of the minutes. Now we know that there are 60 seconds in 1 minute, so the minutes will cancel. So this is going to be, so 5.7 multiplied by 60 multiplied by 60. Now this is two significant figures, so I have to be careful how I write this out. Okay, so this is what I have right there, 20520. Now to write this to two significant figures, right, so this is one significant figure, then I would round this over, so this would have been 21000. All right, and that is now how many seconds? Okay, approximately. So there you have it. And now the last one, thank goodness. Now this one, volume. Okay, so this is now meters and feet. So again, you can go back to those ratios, and that's this ratio right here. 1 meter is equal to approximately 3.28 feet. So let's see it. And that would be, so 1.5 meters cubed. Let's see if now you kind of know what the idea is. You want to get rid of the meters, right? So 1 meter goes at the bottom. 3.28 feet will go up on top. Now it's cubed, so you have to take this and cube it. So let's see what that gives us. 1.5 multiplied by, and, oh, actually I don't need to do that because it's divided by 1. So I'm just going to say multiplied by 3.28, and I want to cube this one. And that's what this would be. So 2 sig figs here. So this would have been 53 feet cubed. Okay, so rounded to two significant figures. Great. So that completes, okay, all of the unit conversions with regards to that question. Let's keep cruising. Okay, number 12. A wound has an area of 0.785 inches squared. You have a package of Band-Aids, okay? Each one covers an area of 4 centimeters squared. How many Band-Aids would you need to cover the wounded area? Okay, so let's take a look at this. I'm gonna just borrow this out, okay? Copy. I'm gonna do it right here. So we have, let me write down all the given information. So we have a wound. So whatever that wound is, right? So let's say whatever that wound is, it has an area, okay? So it has a surface area of 0.785 inches squared. Now you open up some Band-Aids and it tells you that each Band-Aid, so this is the wound area, and each Band-Aid, so that would be, is 4 centimeters squared. So how many Band-Aids would you need to cover the wounded area? All right, now, in order to cover this, well, so you would need to know, okay, so this is per Band-Aid. So this is 4 centimeters squared per one Band-Aid, right? Okay, so let's put that in there. So we're going to be dividing these two. We need the other number. Now, the problem is that this is in inches squared. And so if you recall, so 1 inch is 2.54 centimeters. So let me first, okay, I want to convert this back. So this right here, I'll convert it back to centimeters. So times, so let's get rid of these inches. So 1 inch, 2.54 centimeters. Now I have to square this because of the area. So now putting this in, so I have 0.785 times 2.54. This is going to be squared there. So this is going to be approximately, so 5, okay? And you can certainly write this down for yourself, equals to 5.06. Now this has 3 significant figures, okay, right there. Now, I wouldn't recommend that you round here because it's an intermediate step. So we still have to divide by 4 centimeters squared per each Band-Aid. So it looks like it's going to be basically 2 Band-Aids that are going to be needed because you're not going to be ripping off the other Band-Aids. So this is approximately this much. So I would keep this on the calculator and then just simply divide by 4. And notice that this would give you 1 point, now I can certainly start to round this off, so 1.266, etc. Now this only actually has one significant figure. So this rounded would actually be just 1. Okay, so 1 Band-Aid, okay, that's all that you would need, okay, in order to be able to do this if you're converting to just one significant figure, which is the lowest amount. All right, so that's what you would have in there. Next example, so that was this one right there. Question number 13. A doctor counted 124 heartbeats. In between, so this looks like it's a time, so 1:24:10 p.m. So notice this says hours, minutes, seconds, so hour, minute, seconds. And so hours, minutes, seconds. Based on the doctor's watch observation, what is the patient's heart rate in beats per minute? Okay, so this is an interesting question right there. So let's take a look at this. So what do we have right there? Let me just take this out. Okay, so copy, bring it down right there. Let's paste it. All right. So we have 124 heartbeats. So this goes back to kind of frequency and period. And I can put up a link up above there on those topics for you. So now 124 heartbeats. So that's basically the number of heartbeats that we have, which is 124. Okay, so beats. I'm going to just put it out and write it in full. Now this is between 1:24:10 p.m. and 1:25:05. So we have to kind of be careful and we have to count up. Okay, so how long would that be? So 1:24:10. So this is p.m. And this, okay, goes all the way to, so not for very long, but it looks like, it's almost a minute there. Okay, 05. So from 24, right? So this is 10, so this is seconds. So basically it goes from 10 seconds. Now, each minute is 60 seconds. So that means, notice, this is 25. So that means it goes from here to here, right? So from that would have been 50 seconds, okay, if you were counting that up to a minute. But then it also went for another 5. So this is going to be plus 5 seconds. So in total, the time, T, was 55 seconds. All right. Now, based on this, what is the patient's heart rate in beats per minute? Okay. Well, beats per minute is not per second, right? So if you wanted this in minutes, well, then 55 seconds times, of course, you're going to have to go 60 seconds for every minute. So this is really going to be 55 over 60, right? And you can put that as a decimal if you like, but I'll just leave it, okay, for the minute. So there you have it. So that would be that. And now, in order to find out what is the frequency, now frequency, please, recall. Okay, so if you were doing this, then you would want to be able to know, because it's beats, right? So in this case, so number of beats that you would have. All right. So that's how many beats we would have, and then we want it per minute. So this would be for the total time. Okay, so this would have been total time T that it has taken. So 124 beats divided by, and this would have been 55 over 60. And we can put that into their calculator. So 124 divided by, I'll put it in bracket, so 55 divided by 60. And then the calculator will just work this out for us. And there you have it. Okay, so it would have been that. Now, counting the number of sig figs, well, there's 124, so that's 3 significant figures we were counting. Typically, when you count, you can assume that it's a kind of a perfect measurement there, but I'll still kind of keep it at 3 sig figs. So this would have been 135. 135 beats per minute. And that's the answer to that question. So now next, okay, so that's this one right here. So let's take a look. I'm going to just borrow this out right there, copy it, put it in here, paste, a sample of 15 cc's. All right, so this is 15 cc's. Note, okay, so cc stands for cubic centimeters in healthcare of blood, okay, is taken at a time. Now, if 120 milliliters of blood needs to be drawn, so basically you need 120 milliliters of blood. Now, each sample is 15 cc's. Then how many samples are needed? Now, it says research the unit ratio between cc's and milliliters. Okay, so I'm not going to research that for you. You can certainly do that. But cc stands for cubic centimeters. So this is what it means. So when we write 1 cc, that's what it means. And this actually is equivalent to 1 milliliter. All right, so we basically approximated by 1 milliliter. So what that means is we have 15 milliliters per sample. And now we are supposed to draw out 120 milliliters. This is volume, right? So now notice what we're going to have to do is we're going to have to divide the two. So the units will cancel and tell us exactly how many samples we would need. So this is going to be nothing else but 120 milliliters divided by, okay, and this is going to be 15 milliliters per each sample. So the milliliters are gone, the samples goes back up to the numerator, okay, and we can certainly do that, although we can do that in our heads as well. So this we would have needed 8 samples. All right, so that's what we would need. Now for this one, you don't have to worry about significant figures because of the fact that we're just counting it up. All right, so this is going to be 8 samples within here. Okay, let's take a look. We're getting close there, so almost done. Okay, 15. It has been documented that a patient had 13 headaches in the month of June. What is the frequency of headaches per day? What is the period? What would the period mean? Round your answers to 2 significant figures if needed. So let's take a look at this. For this example, so 15, it has been documented that a patient had 13 headaches, right? Okay, so let's just kind of take a look at this. So 13 headaches in the month of June. And so that would be, so N, let's do that. So 13 headaches, I'll just put head. And now in the month of June, so this is for the whole month. All right, so this stretches out. Okay, so this is a timeline. Okay, start of June, end of June. So we had 13 headaches in there. What is the frequency of headaches per day? Okay, well, frequency is equal to the number, okay, of cycles, okay, that we would have. So number of repetitions, okay, so you can put that C in there if you wanted to. And then this would be per day, so this is going to be per the unit of time. Okay, so within here. Now, T, so June, well, how many days does June have? So you're going to have to go back and think how many days. So June has 30 days, all right? So you can double check that for yourself. So this isn't very difficult. So this is going to be 13 over 30. And that's going to be, so 13 over 30. So this is 0.4. Now this has 13 headaches. I'm going to keep this. Actually, I'll just keep it like this. I'm not going to round anything yet. 0.43333. Okay, so I'm going to just put that little bar over this just so that it reminds me that it's just kind of the threes are repeating there. Now, or you can just leave it as a fraction and that's fine. And this would have been, okay, the number of headaches that you have per day. Okay, so that would have been the frequency. Now, what is the period? Okay, so well, period, okay, is the time divided by the number of cycles, right, or the number of repetitions that we have, or it's just simply, equal to 1 over the frequency. So it equals the same thing. So this is just, 30 over this. So we can do that, okay, and it's equals 2, so let's say 2.307, all right, and that would have been the number of days. Okay. And this is frequency. This is period, sorry. Okay, so for each headache. All right. So now, I'm not going to round again as of yet. Okay, I know that it says round your answers to two significant figures, so we can do that at the end. Now, what would the period mean? Okay, so what would this mean? So now, of course, this would mean if you had regularly had headaches, and it would mean that every 2.3 days, a headache would come about for the patient. That's what the meaning would be. Now, of course, we may not know that because that would mean that, they're evenly spaced out. It may not always be evenly spaced out, but if somebody would tell you that that's the period, then the period would just simply tell you, okay, so that means, your headache is coming every 2.3 days. That's what it would mean. Now, going back to the rounding, so within here, so we can now drop this because if you want two significant figures, then 0.43 is fine. That's two sig figs. And then we would round this. This would have been just 2.3, okay, to two significant figures. That's what you would have there. And now, so here's the last example for us. Okay, here I actually have space. So a healthcare research assistant is reviewing data for a critical patient. All right. The researcher needs to provide the patient's heart rate and heart period, but all that is provided is the diagram. Can you find the two physical quantities? If yes, then find them and provide the frequency in beats per minute and the period in seconds. Okay, well, let's start with the period, okay, in here. Okay, so within the period, well, we would need to, if we have this, and we need to measure this now, so we can eyeball it more or less, right, to be able to find this out. Now, period is the time between each cycle, right? So between each repetition. All right, well, so let's actually figure it out. So we have the time, okay, scale there. So we can try to see, okay, what this would actually be, okay, in terms of its frequency and so on. So how am I going to try to do this? Well, I'm going to try to do this in a sense, okay, so now notice right here, this is going to be, okay, so this is between here, and I'm going to try to actually measure somewhere between here. All right. And so what I can do is I can count, okay, and figure out how many repetitions I have. Now my time, t, so this is 2 seconds, right? So approximately. So from 13, 14, 15. So that's 2 seconds in between there. And now, so how many of these beats do I have in here? So I would need a full cycle of repetition. Okay, so if I would take this, I'm going to just count this up. So let's say, okay, so it's duplicated. So it's going to be, so notice, okay, that's 1 cycle. Okay, it's going to be 2 cycles, right there. Okay, and then we can continue. This is going to be 3 cycles. Duplicate, this is 4 cycles, and it's not going to be exactly 5, so because 5 would have been somewhere over here. All right, so I definitely know, so this is going to be, 1, 2, 3, this is 4. So it's going to have, so the number of cycles, okay, that I have is going to be 4 point. And now I have to kind of be careful and then approximate. So notice within here, okay, I'm going to zoom in. So if 1 cycle would have been somewhere between, so between, here and here, okay, if that's 1 cycle, all right there. So that's 1 cycle right there. Okay, so notice I am, kind of, so I have to subtract this, so how much is this? Okay, approximately. Well, so by guessing, so if I kind of divide this out, it looks like 1, 2, 3. So it looks like it's like a third, right? So it's like, looks like it's 2/3, okay, if I ended, so right here. So from here to here, okay, this would have been, let's say 2/3. Now, I can also cheat, okay, so I can, take out a ruler here, and I can measure, so from here to here, so how much that is. Now notice it goes from 0 to 2, so, and this is what I'm doing, by the way. So I'm just measuring this length, right? So this is from 0 to 2, and then I can find out, okay, so how much have I actually measured it out right there in terms of its, cycles. So it's approximately, I can write this out. This is 1 and then 0.1, 2, 3, 4. So it's like approximately 1.4. And this looks like it's, so one full one is 2.2. All right, so that's what I'm measuring right there. So I measured that, okay, right there, and then I measured this right there. Now 1.4 over 2.2, 1.4 over 2.2, yeah, so it's, so it was about, I said 2/3, right, which is going to be 0.666666, okay, so this is approximately to that. Now I'm not going to do much better than this, so 0.6, let's round this to 6.4. All right, let's get rid of this ruler. Now you can approximate it any way that you like. If you said 0.6, that would have been fine. So I'm going to put 6 and I missed the answer there. 1.4 divided by 2.2, yeah, 0.64. I'll just leave it at approximately that. That's how many cycles we have. So now if I want to be able to do this, now notice this is the number of cycles that I have. This is going to be per second, right? So now if I need this, okay, well then the period is going to be, so this is going to be the time. Now period we want in seconds, so 2 seconds, okay, divided by 4.64, so it gives me approximately, so 2 divided by 4.64. So this is going to be approximately 3. All right, so this is what I have there. And let's round this to 2 sig figs. All right, 2 sig figs. Okay, rounding. And so for that, it's going to be seconds. Okay, right there. Now, I want beats per minute. So unfortunately, I can't, in terms of the frequency. So if I was going to do the frequency in here, so it's going to be the opposite. So 4.64 divided by 2. But that's going to give it to me in seconds, right? So that's going to be 4.64 beats, okay, divided by 2. That's per second. So now, if I want this, I have to multiply this because there's 60 seconds in 1 minute. So that answer times 60, okay, and that would have been 139. All right, and if I wanted to round to 2 sig figs, then this is approximately 140 beats per minute. So that's how you would have been able to find these out. So that's a good exercise because it forces you to actually, look at a graph of a heartbeat and then find out what those would be. All right, that's all of them. Okay, thanks for watching. Cheers. Bye, everybody.